So first of all, let's jump to the table of content. So here are what we will cover in today's presentation. We start from introduction, in which we are going to talk about, which we going to define what does it mean, vibration, also definition of oscillation, sinusoidal motion, and so forth, until we finish our presentation with a conclusion about this chapter. So in the introduction slide, so we just going to talk about the vibration. So what does it mean, vibration? So vibration actually is the periodic motion of a particle or body around a position of equilibrium. This periodicity is a regular and repetitive pattern, much like the rhythmic beating of a heart which circulates blood through our body. Here are an example. The heartbeat is a session of contractions and relaxations. So here are a video in order to understand what does it mean, vibration. As you can see here are vibration of the particles. It vibrates because of that sound. So just a simple video in order to understand what does it mean, vibration. So let's also talk about the oscillation. So oscillations refers to the repetitive back and forth movement around an equilibrium position. Common example here are the mass spring, which is the most known example, or also the electrical circuits. So what is sinusoidal motion? So sinusoidal motion actually is defined by the function gt equals to a sinus omega t plus phi, where a is the amplitude, omega is the angular frequency, phi is the phase, and t is time. So let's also here provide you with video in order to understand the harmonic motion. As you can see here, the harmonic motion for the mass and the spring. As you can see here, this sinusoidal motion, or it's called also the oscillation, the harmonic oscillation. Just a simple video. So let's also talk about the Fourier series, which is one of the most important things here in vibration, because it helps us to break down complex periodic functions into simpler components for analysis. If we give it a definition, it can be like the periodic quantity, which can be expressed as the sum of sine and cosine functions, known as the Fourier series. Here are the mathematical equations which represents the Fourier coefficient, and here are the main equation of Fourier series, or the representation of Fourier series can be used through this equation. So also we are going to talk about the generalized coordinates. What is the generalized coordinates? Generalized coordinates actually are the variables that describe the state of any given physical system. For instance, in a pendulum, using the angle of the pendulum as a generalized forces, to simplify the description of its motion. For example, if we take the robot, the motion of each of its engine, it can be considered as the coordinate, the generalized coordinates. For example, angles, displacement, or whatever can describe the system. So in order to understand this and the motion or the behavior of the system, we have to talk, or we have to include the so-called Lagrange equation. Actually, Lagrange equation, which is the difference between the kinetic energy and the potential energy, which is the fundamental in deriving the equation of motion of any given system. Finally, the conservative system. The conservative system, which is characterized by the force that conserve mechanical energy, such as gravity and spring forces. So the frictional force dependent on velocity, which is also known as the dynamic friction. As you can see here, if we go back to this slide, we can see that the equation of motion, which is Lagrange, equal to 0, but in this one we have here the dissipation as well as I mean the duration of the dissipation. And for this slide, which is the time-dependent external force, we have here also external force. Here are the representation of the Lagrange equation with the dissipation as well as the force. Finally, I think we have been talking about some important parameters or expressions in vibration, such as the sinusoidal motion, oscillation, Fourier series, and also the generalized coordinates, Lagrange equation, which are the most important or the basic tools in order to dive deep into vibration. So let's, for example, give one of the most important systems, like a robot. In order to understand how the robot vibrates, you have to start with the different parameters of it, which can be considered as the generalized coordinates. Then we put them into Lagrange equation, and once we have this equation of Lagrange, we can understand how the system behaves properly. That's all. I think just a brief talk, or a brief explanation about vibration. So thank you so much for your time and consideration. That's all. Thank you.